Hello students, in this video we'll derive geodesic equations on a surface. Let's recall that gamma, a curve and arc length parameter, curve is a geodesic if its geodesic curvature is equal to 0, right? And that's equivalent, of course, to gamma double dot being in the direction of the unit normal vector, right? So i.e., gamma double dot is in the direction of n hat, the unit normal vector to the surface. Okay, excellent. And so what that tells me, that gamma double dot is perpendicular to RU and RV, right? So i.e., gamma double dot is perpendicular to RU, and gamma double dot is perpendicular to RV, like that. Beautiful, okay? Because RU and RV are in the tangent space. And so in other words, if gamma double dot's in the direction of the normal vector, then it has to be perpendicular to those surface patch coordinates, right? So in other words, here's your geodesic frame over here. So if I give you a geodesic on the surface over here, so this is a geodesic over here, okay? Then the second derivative over here of this curve has to be in the direction of n hat, right? So in other words, this is going to be proportional lambda to gamma double dot. And of course, that constant proportionality is reciprocal of the normal curvature of the surface. Beautiful. Okay, excellent. And so now let's use this formulation over here. So what's gamma double dot? So we know that gamma dot, for example, so gamma dot is just going to be what? I'm suppressed the vector notation. Gamma dot is just going to be u prime ru plus v prime rv, right? Where gamma of t, or gamma of s, of course, is just going to be r of u of t, u of s, v of s, and then the primes are with respect to s, okay? So I'm just using the chain rule over here. And so in particular, what this tells me is that d by dt, well, let's start d by ds, what? d by ds of u prime ru plus v prime rv. That's the second derivative. If I dot that with ru, I get 0. And the same thing, d by ds of u prime ru plus v prime rv dot rv is equal to 0, okay? And so now what I'm going to do is I'm going to rewrite these equations in a little bit of a nicer form. I'm going to do the following. I'm going to put this ru inside here and this rv inside here, and that gives me a penalty, so I have to compensate for that by the product rule, right? So in other words, what this tells me, these two things tell me the following equations. They tell me that d by ds of, I'll put the ru on the inside. So if I put the ru on the inside, I have ru dot ru, so it's going to be a u prime e, and then what? And then a v prime f for the first and second fundamental forms. And then what have I done over there? So now I've put that in the inside, so I have to compensate by subtracting off the terms in the product rule. So that's going to be minus u dot ru plus v dot rv, and then dot the derivative with respect to s of ru. And what will that be? That's going to be u dot plus ruv dot v dot. Okay, that's the second derivative, so I've compensated for that correctly. And what will this tell me over here? This is going to tell me d by ds. Now I'll put it on the inside, so I'm going to have a u prime f plus v prime g is equal to what? Is equal minus, of course, and so these things have to add up to be 0, of course, right? So that's 0. So let's put a 0 over here. So I'm going to subtract off the other terms we get. Minus what? Minus u prime ru plus v prime rv dot. Now I have to do the derivative of rv, right? So it's going to be ruv u dot, and then in rvv, v prime is equal to 0, right? So in other words, I just sort of rewrite it in this more elementary fashion, right? So now, of course, we're going to have terms of the following forms over here. So let's do lemma, right? So what's my lemma? what terms are we going to have to choose? So this term is perfectly fine, right? We're going to leave that as it is. Now what will RUU dot RU be, right? So RUU dot RU is really 1/2 the derivative of E with respect to U, right? Because what is E? So this would be 1/2, of course, what? RU dot RU with respect to U. And by the product rule, that's going to be 1/2, and then 2 copies of what? 2 copies of RUU dot RU, and so that verifies by the chain rule that this is going to be RUU dot RU like that. So in other words, this expression over here is 1/2 EU. What would RUU dot RV be? That's going to be what? That's going to be the U derivative of F, right? So then similarly, RUU dot RV would be 1/2 FU. Okay. R what? And then finally we have RV, then R what? We'll have 2 of those things over there because I'll have this B derivative with this thing over here, and then this B derivative with this thing over here. So 2 of those expressions. Then finally, what will be RUV dot RV? That's going to be the U derivative, 1/2 the U derivative of G. Excellent. So in other words, all of the expressions over here, this expression dot this expression dot this expression dot this, and this expression dot this, are all U derivatives of either E, F, or G, right? So the first geodesic equation, call it. So hence our first equation 1, is d by ds. What's d by ds of E U prime plus F V prime is going to be equal to what? It's going to be equal to, well, what's going to happen over here is going to be equal to, I'm going to throw those on the other side, and I'm going to have a 1/2 in front of everything over here, 1/2. And then we have an E sub U, and that's going to be U prime, so that's going to be U prime squared. I'm going to have 2 F sub U's, U prime, V prime, and then what? And finally a plus GU, V prime squared. Beautiful. By exactly the same reasoning, d by ds, the second equation, I'll have an F U prime plus G V prime is equal to 1/2. Now instead of what? It's going to have, on the second equation over here, we're going to have B derivatives, right? So V derivatives, that's going to be a V derivative of EU. That's going to be a V derivative of G. And we have 2 V derivatives of F. So we'll have a what? Of an E V, and then U prime squared, 2 F V U prime V prime plus G V V prime 1 squared. So, beautiful. So these are the geodesic equations. On a surface. Now it turns out, these are equivalents to what? Are equivalent, you're saying U double prime plus gamma 1, 1, 1 U prime squared plus 2 gamma 1, 2, 1, and then U prime V prime plus gamma 2, 2, 1, and then a V prime squared is equal to 0. And then finally over here, that is B double prime plus gamma 2, gamma 1, 1, 2, gamma 1, 1, 2, U prime squared up to gamma 1, 2, 2, V prime plus gamma 2, 2, 2, V prime squared. It's equal to 0. And these are the those are the equations of the geodesic equation we previously grow on a surface manifold construction over here. In other words, geodesic equation gets from the ordinary parameterization of the surface, this equation in terms of Christoffel symbols, by writing down the terms of the Christoffel in terms of derivatives of the first fundamental forms in terms of U and V. we have a huge laundry list of those equations in which we're able to compute the Christoffel symbols in terms of the derivatives of the first fundamental forms. So now by just pointing those equations, I see that they're exact equivalent to the ordinary formulation of the geodesic equations we've previously seen. So in other words, we have that these geodesic equations over here, these geodesic curves defining in terms of geodesic curvature vanishing, are exactly equivalent to the curves which locally minimize the distance between 2 points on a surface. So I want to go from point A to point B on a surface, I have to find the geodesic that traverses it for those 2 points. And we're going to see in further videos how we can use these geodesics to actually form a coordinate system on the surface, which puts the first fundamental form in a particularly nice, the first fundamental form in a very, very nice canonical representation, which allows us to compute the Gaussian curvature in elementary ways. If we're able to compute these geodesics, it gives us a mechanism by which we can construct geodesic coordinates and find the Gaussian curvature of a surface in via a very simple calculation without having to resort to one of these complex Gauss formulas in terms of a 3x3 determinant in terms of derivatives of the first and second fundamental forms. So we'll see how the geodesics can help us find Gaussian curvatures and even mean curvatures in further videos. Thank you very much.